Right. Okay, let's see. Need to put a few more of these things away. All right, I think we're set. All right, welcome. Good morning. Got the rare Saturday morning Escaladiata, which is pretty cool. Send it up. Wrapped up here above us in the live chat. So let's go with this one over here, and then let me do this. All right. Yes, so hello, good morning, welcome. For anybody that's new, my name's Tim. I go by FoamGuy on GitHub and Discord. And at this time of the week, roughly around 10 a.m. Central Time, each week on Saturday, I stream and I'm here working on some stuff related to CircuitPython. If you are new and you don't know what CircuitPython is, you can learn more at the main website, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. We are using today, in particular, this PyGamer microcontroller. Mine's in a case, so you can't see the board, but it's the same device right here. But the general idea of these microcontroller devices is they're like tiny computers. If you choose to use CircuitPython with them, you can just plug them into your computer. They show up like a thumb drive, and you can edit a Python code file on that thumb drive in order to actually program the microcontroller. Whatever Python code you put in there, when you save it, it will execute and run on the microcontroller, on the little computer chip. That's the very, very high level view. There are lots of different kinds of these. You can see here there are 550 different ones that support CircuitPython. There are, of course, many, many more out there in the world that don't support CircuitPython yet. But the thing is, like, they kind of all have their own specialties, right? So lots of them are very general, where they just have all these pins and you can connect whatever you want. But others are more specialized, like a little kind of tablet thing, a little macro pad, some alligator clip, like learning-based devices, some very small ones that are minimal, little handheld gaming type thing, like the PyGamer that we have here. So there's all kinds of different ones of these, but all the ones that are here, of course, on the downloads page are the ones that you can use CircuitPython with. I am diving back into the shape intersection. So if you happen to like geometry and or CircuitPython and you have not seen some prior work on this and you're interested in it, you can go back a bit in some of the past streams in the last, I don't know, maybe month or two. And you can find some other instances of working on this. I'm hoping to finish up the last couple of ones here today, if not very soon. So the first thing I do actually need to do, though, is I just made a build right before I started up the stream, and I do need to install that. And then we need to basically check and see. Where's the reset? Oh, reset button's on the right side. We need to check and see where the core implementation is at. So my recollection of it is we basically have one major one that I would like to do left, which is going to be polygon rectangle. Because with Vectorio, the drawing utility in CircuitPython that can draw various shapes, it has a circle, a rectangle, and a polygon are the 3 shapes that it has. So I like to kind of implement the intersection tests for each of those 3 shapes with each with each other. So circle, rectangle, circle, circle, rectangle, rectangle, and then like circle, polygon, and rectangle, polygon. I probably won't do polygon, polygon, but somebody else could add it if there's interest. We want to copy this one, so that's going to be in build PyGamer. I think it's P something? PyGamer boot. Yeah, there we go. And then I also need to change the CodePy, which is currently written for the Python implementation of this, because I did make a Python implementation prior to starting to add it to the core. So there's this intersection, which is a Python file. So what we are going to do is just comment this part out and duplicate it as well, because we want to basically have another copy of that. And then what I will change is that we won't call intersection anymore, and it will be the Vectorio one. So that's just in Vectorio polygon circle intersects. And then my IDE doesn't know about this because it's not in the stubs or anything, obviously, because I've just put it in the core in that build over there. So we do say we want the points. We are just taking integers for x and y instead of a tuple here, so let's change that. Cx, cy, cr, all as plain numbers. And then there is a padding. I'll leave the padding off for right now. We'll see what it does with it off. And I'm gonna, does the other one have the same palette? I'm actually going to change the color of the big shape instead of the little shape. Static polygon is going to change color instead of moving circle. And then let's make the yeah, we do want to have some padding, it turns out, and let's make the circle blue. Or whatever color. I think that was blue, right? It's too bad, like, I know this, if this was like this, maybe, would it do it? No, it doesn't do it. Like, if you're in CSS code, you can see a little swatch preview of the color. That would be kind of nice. That's the red, that's the green. Yeah, that must be the blue. So index 1. Color index will do 1 instead. There we go. And then it is currently, well, 2 things about it currently. It is currently affecting only the edge. It's only testing for edge collision or intersection. So the outside edge of the circle intersecting with the outside edge of the polygon. If the circle is fully contained by the polygon, it does not register as true. And then the other thing about it currently is these diagonals make it weird. Sometimes you can be intersecting on the diagonal, but it's still red. And that is to do with the padding. Basically, that is a consequence of rounding and the fact that a literal 1 width line is a very small thing. So we can actually just, for padding, we could actually just pass a little bit more, and I don't even think it needs to be that much. And it will fix those diagonals. Oh, extra positional, I guess that one's a named. Yeah, so now the diagonals behave way better. So that padding essentially just gives it, I mean, like the name suggests, at least in my brain, it gives it a little bit of padding around the line. So instead of actually considering it as a literal 1 pixel wide line in the geometry, it's going to add, 0.1. Well, I'm calling them pixels in the geometry. They're not really even pixels per se. They're just, I guess, arbitrary units, numbers. But anyway, it's just adding a little bit of a buffer zone outside the line, which then once it gets rounded off in our code in float numbers, it still ends up being true. Okay, so that fixes that. So we don't have, the only thing we don't have is the inside of the polygon. And do I want to do that first, or do I want to just jump into polygon rectangle? Let's look. I think so in intersection, I think that was actually implemented already too. The Python implementation of this. And the way that I did this was I ended up having a Boolean that you could pass. But truthfully, the reason why I did that is that the code that I started working from has this warning. Okay, so it says it's not going to work if it's fully enclosed. In most situations, you don't care. If you do need to know when it's fully enclosed, this says you can add 2 more lines to polycircle function right before the final return false to test if the center of the circle is inside the polygon. And so they basically just edit right at the end here. Well, this is polygon point. Polygon circle. Yeah, so they have the code comment here as well. The above only checks the edges. The following code will check the inside. And the way that they do it is they go Boolean center inside equals polygon point. And then if that's true, return true. Otherwise, return false if we made it to here, because we have our return true for the edge collision here. And the reason why they warn against it essentially is that polygon point, if we go and look inside of it, here, it's looping over all the vertices in the polygon. Okay, and then polygon circle is also looping over all the vertices in the polygon. So they're basically saying, don't do this unless you really, really need it, because you're going to end up looping through all the points of the polygon again, which is inefficient because you already looped through them up here. Which makes total sense in my head, but the next place where my brain took it was like, well, we're already looping through the points. What if we just did the test inside of there, right? So like they have factored polygon point into its own function with its own name and its own logic and all this stuff, and that's really nice for reuse. But this loop is the same loop as this loop here. Instead of having this as its own function down here, we could actually just add another chunk inside this for loop that has all the logic from this. And this logic is basically just check a bunch of these greater than less than things and then set a Boolean, like flip-flop a Boolean back and forth based on the results of this like magic formula, basically. Magic like greater than less than math with the current vertice against the other stuff it's looking at, the circle in this case. And so in my head, I was like, well, if we just do that logic in here, then we're not looping twice, and we don't really care as much about the efficiency. I mean, it is more work to do these, greater than less than calculations and the division, and there's math in here, but I don't think it will be a big deal. And the way that I implemented it in Python is I put a test contains, you could pass true or false, kind of in anticipation for doing it more like they have it here, so that I would have a Boolean where you could say, like, yes, test contains, I do want to do that, and then, it would say if test contains and, the result of this, or really it would say if test contains is true, then call this one and then do the bit inside of there. Otherwise, ignore that and just go with the edge detection. But since this is actually all collapsed into the same function, I don't think there's really a need for test contains. I think I'm leaning towards, in the C implementation, not having that at all, and instead it's just always true, and we're going to do this inside of the for loop, which we already have. Which means we don't have to mess with the arguments, which is nice, because that is back into shared bindings. And instead we can kind of go into here. We're checking the line intersection for this. It's actually going by pairs of points, technically. We're looping over the vertices, but we are also getting the next vertice and building a line out of it, logically speaking. We can't do comments? It's kind of awkward. Anyway, it's all messed up in the... And I'll actually grab this bit here as well. It's looking a little messed up. Doesn't want to let me have it in either, so it's fine. Maybe that was why? Nope, still doesn't want to let me tab it in. That's fine. We'll just keep that. That's just the Python code as a reminder here. I will start from it for the C code as well, though. But or doesn't work like that, and doesn't work like that. And the names of these are all probably wrong. So cur point 1 would be cur y, because that was going to be a tuple in Python land, and so 0 would have been x and 1 would have been y. Next point 1 would have been next y. Next point 0 will be next x. Cur 0 will be cur x. Circle y. We have those. Circle y and circle x. We have cy and cx. And we probably need cr too. Maybe not, actually, because we're just doing the center point. Oh. Boy, the parentheses are a bit of a mess here, huh? Okay, so it's just all of this together, which is an or in and of itself, and then it's an and with that. With cx less than this whole formula. Okay. Yeah, the formatting is... Okay, so we need to have a Boolean that we can flop back and forth, and we need it to exist outside of here, which is just going to be called polygon contains center, or contains point. What does it start on? Because we're just flopping it back and forth, so it has to start on something. It starts on false. Stands to reason, I guess. Oh, it's like erasing my indentions. That's annoying. Also, it won't auto-complete anything. Like, it's very confused right now. The IDE here. Oh, goodness. What has happened? Okay, copy that. Okay, it did paste. Well, no, it didn't paste. I just started writing that. But we lost another line, I think, right? Because I wasn't on... Whatever. I think I actually do like that, since this is kind of a multi-line condition here. I like the padding between. And then before we return false, we will also just go... If... Oop, wrong way. Okay, we need that, but we also need... These... Do you need true? I don't know. I kind of prefer it, but I'm not sure if you need it. Okay. Does it build? I'm gonna guess no. Comparisons... Oh, okay. In Python, we can do like three-way in-between comparison. And it looks like in C we cannot. So we are... This is going to get uglier. Okay, fair enough. Let's... we'll go ahead and preemptively put these on their own lines. This is going to get bigger, so... All right, so we are saying essentially, I mean, this is an and, right? This is like cur y is greater than equal to cy, and cy is greater than next y. Okay, do we have one of those here too, or no? So we have cx less than, and then just math, right? Yeah, just math. Plus, minus, times, divided. Just math. All right. Thanks, compiler. All right, that seems promising. so now the inside check works as well. That was relatively painless. Okay, so we can nuke all of this. This did not end up as bad as I had imagined. I do think I'm just gonna put that back there. Let me keep that for the moment. Okay, and now we'll be able to use a lot of this. Well, maybe not a lot of it, but some of it. So we are gonna need Vectorio. We're gonna need a few others though. Because this is based on Polygon Rect is based on, yeah, so they have the same warning here, although they did leave it turned on instead of commented out this time. But I think we'll handle that the same way, right? Like this is effectively the same. The same stuff was happening here. So like this bit's different because it's, well, it's using p vectors for one thing, so it has like VCY, whereas we have single variables. And then this, I think we are already handling. Yeah, I did it slightly differently, but yeah, we're handling it there because that's basically just making it wrap around. So when you get to the last point in the list, you still want to evaluate a line, right? We still need 2 points, so we want to go from the last point to the first point rather than anything else, which is what we want to do. And that logic is happening here. Okay. So yeah, we'll do this the same, but we do need line, and we do need line rect. And line rect uses line, so we should start at the bottom with line, which we should presumably have the Python implementation for? Question mark? I don't know if I did rectangle polygon. Line contains point. Circle contains point. Line rect, line, yep. Okay. And conveniently, this is already broken out as individual values. I don't know, how do you catch that, though? That's going to be odd. Can you do that? C plus catch 0 division? Yeah. Okay, so we need an if statement. Okay. I'll take this for reference, but we won't be able to use it directly. Let's back off of this one. Let's do line first. Line intersects. So this one is gonna take what did we do in the Python one? Right. Okay. Yeah, I think we're just going to do the same thing. Is there a padding? No. Okay. Inline, we need a shared bindings for that. Okay, line. Boolean checks whether line intersects with another line. Other line, I'm just going to call it other line x3 still, but we'll denote it with other so that it's clear that it's the second line, basically. Or, I mean, it doesn't matter which one's first or second, really, but it's the other line of a non-determined order. We have no circle args, but we want an extra copy of all of these. Circle args. Oops. No padding. Okay, args, parsol. None of these. Duplicate these. Wait, I feel like we've done this bit a bunch of times at this point. Maybe I should have been doing, like, replace? I mean, I didn't go through and duplicate it all for first anyway, so we would have been replacing a bunch of times. Okay, we have no padding. We call line. Pass in the correct arguments. Yeah, we return true if that returns true. Cool. Okay, we have a shared binding. We need another, we need this thing. Entries list, what is that? I don't know, I remember what it's called. Globals table, that's right, there we go. We need this one. Line. Okay, so that's in bindings. That's in H. We just need it in module now. Which it will just go down here. I'm gonna start with line circle because that's gonna have a large chunk of what we want, just like we were doing before. Dump the circle stuff, we'll duplicate that, we'll go 3, 3, 4, 4. Okay. Now we can have the Python implementation in a comment for a moment. and we need to calculate denominators first. So int denom 1 or denom a. We're doing distance, so if we're doing distance a, then denominator a, it makes pretty good sense. We have variables are all the same names, so that should just work. And we might as well just do both at once. Oh, interesting. They are the exact same. Then we don't need to do it twice, right? I mean, they're literally the same, so we just need denominator. y4, y3, x2, x1, x4, x3, y2, y1, double parens. Yeah. Okay, so then we can just go, so it was catching divide by 0 and returning false, so we're going to say if denom is false, parentheses, because we're not in Python, those are not parentheses. That shouldn't be true, that should be false. This is obviously not false either, that should be 0. Okay, so if the denominator is 0, then instead of trying to divide, we just return false. So we don't catch the error, instead we check if there's going to be an error. We do what we would have done if there was. And then now we can do dist a equals all this stuff over the denominator. This probably needs to be a float, actually. Maybe this needs to be a float. I mean, it shouldn't be, right? These are all ints and we're not dividing. We're only multiplying, minusing, and timesing. I already said multiplying. We're only multiplying and minusing. Should be an int, I think. We are missing a boatload of these things. Okay, so the numerators are different, which makes sense. And then we have dist A, dist B, and then this is returning. We have another one of these things going on where it's using the try comparisons or whatever. So we have to simplify this a bit. I mean, could we still return like a Boolean expression? I think maybe, I'm not sure. I get like in my head, the if is actually a bit more clear when you're reading it. So I'm going to go with that, but it may work the other way and it may be something we want to change ultimately. So if 0 is less than dist A and dist A is less than or equal to 1, these are probably not necessary strictly, but again, it's like in my head, this makes it a bit more clear. So that, and also say 0, so just the same thing, but for dist B. Oh, less than equal, yeah, less than equals, both sides, and dist B less than equals Return true. Return false. All right. To my eye, that looks like it should work. We got shared bindings. We got H. Added it to the globals thing. I think that's everything? Question mark? Dice. Defined but not used. Did I... Should be common how? Shared bindings init C. Oops. For one thing, I forgot to rename that. This is wrong too. Wow, we're like freaking out of the green screen universe there, huh? Notice, okay, there we go. It's not much to see here, but I'll at least try to show you. We will then update the code to make the moving thing a rectangle, and we'll test against like one of the lines of the rectangle. I'll just make it a square, but square is also a rectangle, luckily. It's probably already one, actually. Maybe? Yeah. We'll comment out moving circle, bring back moving rect. I'm gonna keep going with the color like this. I think I like the big thing changing instead of the small thing. I need to flop all of these again. Okay, so line. And what we're going to use is the top line of the polygon, which I'm pretty sure should be the first line of the polygon. So the first 2 points, 0, 0, and 0, 1. Then those. Oh. We need to add these. Our polygon, our Vectorio polygon has points which are in their own coordinate space, not the display coordinate space. And the display coordinate space is where I want to test for the intersection, because that's where I can visually see the intersection. Like, the function doesn't care whether the line is visual or not, but it sure does make it easier to test if it is. So we need to translate from the sort of arbitrary own coordinate space of the Vectorio polygon out into the display coordinate space by offsetting by the XY. I'm pretty sure that should work, hopefully. And then that's our first 4 points, which represents our first line. Well, it's our first 4 coordinates, 2 points. 4 values, 2 points. That represents the first line. So then the next line is going to be moving rect, and I think we can say X and Y, and that should be the top left, I'm pretty sure. And then what we're going to do is moving rect X plus width, and then Y. We don't want the height, though. I just want to go the top line, basically. Okay, so if I am getting it right, then we're basically testing the top line of the square, which will move, against the top line of the trapezoid. Oh, that's probably not the best idea, is it? We should use a vertical line of the square. Should use a vertical line of the square. And so in this, instead of here, we should go down. So let's keep X, and let's do... Yeah, so I think then we're doing now the left side of the moving square against the top of the trapezoid. Ooh, okay, interesting. We are off by a lot for some reason. Hmm. Maybe that's wrong. In my head, that seems right. But something's definitely wrong. Okay, this is all wrong. That was an interesting guess, but Not quite, thank you though. Okay, so this should all be the exact same, but now I want to print these. Okay. Yeah, I mean, that seems fine. Why though? I wish it would not pop that thing up, and then, like, would instead just focus what I click on. Would be cool. So that all seems fine. Um, does the Python implementation work? Maybe the Python implementation never worked. We copied a non-working implementation into C. No, the Python implementation works fine. Okay. Let's do some printing. that's hopefully going to be F for float. All right, while that builds, I'll be right back. So conversion from float to double. Okay, did we mess this up by calling this a float? Okay, BRB. It's the time of year where we must employ the sunblocker 9000. Okay. It's looking better so far. Nice. Okay, yeah, apparently float and double, important difference. Yeah, so now the left edge of the tiny square, whenever it intersects with the top edge of the trapezoid. Let's make sure the diagonal works, and then we can move on. So that should be pretty much just use the second and third points instead of the first and second, which of course have indexes 1 and 2. So I'm pretty sure the points in the polygon are first point, second point, third point, fourth point, and then it automatically connects itself. Okay, admittedly, the vertical against the diagonal is actually tough, but it seems to be working fine. Against this diagonal, I guess. If it were not as steep, it would be easier, but... All right. +1 in the win column for printing it out. Although, is it printing? Why is it not printing? Oh, we are on the Python implementation still. Yes, okay, we got a little bit ahead of ourselves there. So does it even actually work? It's the real question. They're, of course, on the diagonal now. Okay, I mean, it is better than before. Yeah. Seems like it. I'll go back to the top. Oh no. So the diagonal line works fine? Did the diagonal work fine? Okay. Right there, I feel like we're outside a little bit. Yeah, there was one there too. I can see black in between. Okay, did not work. So we never seem to have the denominator 0 problem. And admittedly, I don't remember the exact case where it comes up. They actually don't even catch it here. Well, I don't know. Maybe does JavaScript let you divide by 0? I don't know. This might not be Java. I think I don't know if this is JavaScript either. I think it's maybe processing or something. Oh, this is not distance. This is direction. Does it matter that these are all floats instead of ints? Are we doing a bunch of extra rounding because of that? Okay, now wait a minute though, because I bet we have mucked this up. This is probably wrecking it, right? Does and take precedence over greater than less than? Wouldn't we have that problem in the other code too? Do we just get lucky here? My only guess is perhaps the and was taking precedent, and so the first thing that would happen is I mean, that would make no sense though, right? Because it would be dist A and dist A, which is gonna be a Boolean, and then it's gonna get compared against numbers? I mean, we're getting weird behavior. But I feel like we saw some where dist A and dist B were outside of that range. Or for instance, right now, dist A is 0 and dist B is 1, which are, we know now they're actually directions, not distances. I don't really know what that means. I guess maybe they're in radians? I'm not sure. No. Directions. I don't know what that means. But that should be returning true, should it not? I mean, we're outside, so we're not intersecting, so it would be bad if it were returning true. But if dist A is... Oh, I'm scrolled all the way at the top. Okay, I'm not looking at the live. Yeah, I don't know what direction. Why would that be direction? Wait a minute. Oh. Wait a minute. Okay. Well, the original code doesn't use those three-way conditions. Instead, it just says greater than 0 and less than 1. Which is, I guess, the same thing we ended up with, but it's backwards. I did 0 less than equals... Is that right? I don't remember if I ran this one or not. Is this the same as dist a greater than equals 0? Yeah. So maybe it's like logically extending that line forever? That might be it. I think that might be it, actually. That's what it looks like it's behaving as now, if we're still on the diagonal line with the top of the square. I think we are. Yeah. What if we do the top of the trapezoid with the... Oh wait, we were on the diagonal and a vertical. Hmm. Um... Hmm. I mean, it's not just extending the line forever, though, right? Because if I get out here, it becomes false again. And if we're testing against the top line of the trapezoid, then if it extends forever, then out here we would stay green. Am I not allowed to just treat these as ints? Do I need to, like, cast these to int or something? So, I mean, here, this is not extending logically. It's not counting as an intersection out here. So the outermost parentheses are this set, which is around the numerator of this division, and this outside set, which are around the denominator. So you would calculate all of this first, all of this second, and then you would do your dividing. And then, of course, in the process of doing all of this, you would have to go in and do parentheses, 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 times those two, and then subtract. Is the order of operations different? I mean, that seems like a silly question. But I'm also struggling to figure out what could be the difference when we have the Python version that works fine. The logic is like all the same. So here we have our denominator. And its outermost parentheses are on the outside, which are not really necessary in this case. It's going to go and do parentheses, 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 parentheses. It should then times these two, and then subtract. All right, well, at least the circle part was nice and easy today. The denominator is always exactly 500. Why does that keep... Oh, because I keep bumping my hand on the mouse. Okay. I mean, that's probably wrong. It's based on a bunch of values that are moving, so... Is it? Maybe it's only based on the static ones. Well, we don't pre-calculate the denominator. Yeah, I mean, it uses x1, y1, x2, y2, x3, y3, and x4, y4. It uses all 8 coordinates, all 4 point pairs. So should be moving. Is this custom made? The PSP looking device. No, it is. In fact, we have it pulled up right here. So I don't know how much you know. You let me know if I'm telling you stuff you already know. But basically, I'm working on CircuitPython stuff. CircuitPython is a version of Python that can run on microcontrollers. And then this PyGamer device is the device I'm using. Starts with making small game devices, then IEDs. There will be no IEDs or nuclear bombs. Yeah, no, we're definitely not going to be making any of those. I don't know where that progression would come from. That seems a bit out there. Okay, where was I? Yeah, pre-calculate the denominator. I want to see if the Python one is the same. It should be. I'm pretty sure this should be changing though, right? We're using all 8 values that are coming in, and we know that 4 of those values are changing in our case because we used one static line and one moving line. Okay, so first of all, in the Python one, if we do pre-calculate the denominator, and we print it out, does it change? And is it 500? And did I change to the Python one? Yeah, it looks like it. Although, okay. Yeah. Okay, it is just always 500. That's actually correct. That's really weird. So we know it's 500, which means we know that it's not ever catching zero division. What's CircuitPython? Some Ultra Nerds Club stuff? I mean, I would not probably characterize it that way. It's a version of Python that can run on microcontrollers. So all these devices on this page are different microcontrollers. CircuitPython is one way that you can program your microcontroller. If you choose to do it that way, then when you plug it into your computer, it shows up like a thumb drive. So like CircuitPy, this looks like a thumb drive, right? It's just a file or a folder with a bunch of files in it. You can edit the code file, and when you edit it and save it, the microcontroller, the little chip that's on these devices, will execute the code for you. It's quite technical in nature, so if that's what you mean, then perhaps, but okay. I mean, so the next step then, I guess, is we should, well, we are. In here, we're printing those. And I mean, we know those are going to be wrong in C and right in Python. Okay, so right off the bat, one thing I notice, the dist, like the variable that I have called dist a, which we now know is not a distance, and so I should rename at some point. It's like, yeah, I just tried to point at this physical device right here, but move my finger over to here to point at the terminal, which obviously is gonna work. Anyway, the first one of these is dist a, and when I move horizontally, it changes. Okay, but dist B doesn't. It stays. 2.9 it was for a while, 2.7 it is now, because this is a joystick and I bumped it down a tiny bit. Or maybe up, I don't know. Anyway, though, when I move horizontally, only dist A is changing, and when I move vertically, only dist B is changing. And that is not true of the C implementation, I don't think. So these are our dist A and dist B. Let me just make sure that's right. Should have done commas before. I mean, would this be messing it up somehow? Is float and double different? D is digit. Let's go look that up. C print string format double. F and LF. What's the difference between LF and F? Okay, it seems like either is okay. So when I move, okay, so I was wrong. Only one is moving, but it looks like we have a rounding problem, right? Because we're always only 0, 1, or 2. Whereas in the Python implementation, we were doing the whole gamut there. We had like 0 point whatever. We're always on whole numbers. In fact, we're always on whole numbers. Also, I drove outside the screen and didn't know where I was for a minute. Yeah, we must be rounding. My guess, I feel like I've seen this before. I think if these are ints, for some reason, it rounds the results. Which is quite inconvenient for this, because okay, is that even legal? Can you just set a double equal to an int? Let's try to compile that first. Unused variable. Comparing floating point. Well, I mean, we know that's 500. I don't know why it's always 500, or why I felt the need to catch the division by 0 error. I mean, I swear that got raised at some point. I mean, it seems like we are allowed to do this, but it is now mad that we are comparing a float. Apparently we're not allowed to do that. How do we check it for being 0? Just, we have to put it to an int first? So if it's greater than equal to 0 and it's less than or equal to 0, then it must be 0. That feels kind of against the spirit of the error, because we're testing the same thing, but the compiler's happy, so... Alright, this is going to be quicker, actually. Just go and put a D in front of everything on this. Okay. Jump the gun again. Getting a little happy on the old copy command there. Hey, thanks for the follow. X3B OOD 502. Name sounds like serial number, kind of. Pretty cool, I like it. Okay, now we don't have round whole numbers. So with a bit of luck, hopefully we have a thing that actually works. Oh, okay. That's auto reload. Should turn it off, but haven't yet. Okay, yeah. Now we're there. Okay, when you do math with ints, even though you have a divided by, you end up with ints coming out, I guess, which is different in Python, right? In Python, if you do math, well, if you do divided by specifically with an int, I mean, there's not really, is there an int? I don't know. Python's just different because numbers are numbers and they can have decimals. But anyway, in Python, if you do like 8 divided by 2, even though that is 4, it's going to give you 4.0. It's going to explicitly have a dot, be a float, be a double, whatever you want to think of it as. That seems to be not the case. You'd have to pass it to int or floor. To right, yeah, to turn it into an int. That's true, yeah. And how's it going as well? Tithe, yeah. So but the true problem that we're having is we wanted the reverse, basically. So what was happening is that in C that's different. In C, if you say, I mean, this is my hypothesis based on what I saw with this code. I have not distilled it down to this very small use case, but it seems like from what I saw in C, if you have int 8, well, you know, int a8 or what, like if you have the int 8 and you have the int 2 and you divide them, you'll end up with the int 4. It seemed like, or at least the whole number 4. I think it did still have a decimal actually, but we put it in a double afterwards and we printed it with %f, so like I probably turned it into the double. I think it came out of this as an int, or at the very least it always came out as a whole number. So 7/2 was always coming out as 3.0, if not just 3 as an int, and then I was turning it into a double and we were getting the .0s on it. But that was going on, and to fix it, we created doubles for every one of our ints, basically. We could cast each one, I guess, and it would work as well, if casting is a thing in C. Casting a thing in C? IDE seems okay with it. Casting is the same. Nice, okay, thank you. Yeah, and so I was expecting just automatically, because of the divided by, I was expecting this whole thing to evaluate to a double that was not a whole number in the majority of cases. Like, you know, eventually you get it coincidentally, it will be a whole number, but in most cases it will likely be a decimal that's not a whole number. But instead, when we were doing ints, we were getting whole numbers. But we are not anymore, so I can get rid of this. I can get rid of this. I still don't know what triggers this one. I don't know if this is necessary. I put it in my Python code, and I swear I had that exception get raised at one point, but I don't know how now. I was curious if it would accept diving ints into float variable. Diving ints into float variable for result? Or if forced to cast. Was curious if it would accept probably dividing ints into float variable for result. I think that it will not do it automatically, because the code that I had before was the exact same here. I just wasn't using the dx, dx, dy, dy. I wasn't using the d ones of these. I was just using these ones. And I did still have double here, and we were still doing divided by here. You know what we can do? We can take a brief detour. Actually, I've been working on this a bit. And this seems like something that would be nice to actually know the real truth of. Number touch number types .c. I probably didn't need that to be its own thing, but whatever. So I have been actually trying to like learn C instead of just write CircuitPython code. Do the best that I can because I know what the Python looks like. So if we have int a equals 8, and if we have int b equals 2, and then if we say double result equals a over 2, a over b, and then if we print it, my hypothesis is that it prints either, my hypothesis is that it will print 4.0, maybe 4.0.00000. We do need an F there. We want a result there, and then I need to remember how to compile. I think is it GCC? Maybe it's just GCC. Options file. I think we want. So I could just do that, but I want -o. Is it -o file? Yeah, I want -o. GCC -o number types dot. It's been calling them .out, which is odd, but we'll just stick with that. And then number types .c. That, and then we can run it with number types .out. Okay, yes, 4.0.0. But and now if we make this 7, we get 3.0.0. Is that true? Yes. So we got 3.0.0 instead of 3.5. But if these were just doubles, double DA is 7.0 and double DB is 2.0. Then we will get 3.5. Yes. Okay. Cool. I've run into that before. I don't know what language. Maybe Java is like that too, or something. I've definitely dealt with that before, where the numbers that went in being ints resulted in the math coming out as an int as well, even though we were storing it into a double, and even though 7 divided by 2 is 3.5, and in Python that would have given you 3.5, but I have run into this before. It must be Java, but I can't remember for certain. Python calculation result can change ints into float when the division is involved. C would always truncate the result to be an int. Magic we know is Python. Yep. It's good at spoiling me and that stuff. Okay. So yeah, that took most of the time, unfortunately, to figure that out. But we did make it in the end, and we do have a working line intersect function, which could ultimately be used by the rectangle line which is pretty much just a series of line intersect calls. We do 4 lines. Essentially we test our incoming line against all 4 lines of the rectangle. And if any of those intersect, then we return true. Okay. If I run into a lot of trouble, I will stop. I will not get all the way there, but I'll start this. We'll give it a try. So we're going to take a line, and then we're going to take a rectangle, which we will call these things. Line rectangle intersects. Okay. Shared bindings. You don't need that. Okay, line rectangle. We can have the line coordinates. We can have the rectangle stuff. Those. Add these. It's nice that we have at least one function that takes every kind of thing, so that I can be copy pasting all these arguments and not having to redo all of that every time. Okay, this was what I forgot last time, so we're doing better already. Okay, think that's everything here. So then we just jump to shared module. Give us a new one of these. Should have an RH in here somewhere. All right. Oops. I wonder how VS Code treats the CircuitPython core project. Is anybody who's watching, have you used VS Code on the CircuitPython core? I'm using CLion, which is supposed to be the C IDE, but for whatever reason, the structure of the CircuitPython project, I think, throws it off, and it doesn't give me like any. It doesn't give me like hardly any syntax suggestion help, and even just simple stuff. Like, it's not tabbing in, right? Like, that's just stuff that it does all the time for every language, but for some reason it just doesn't figure it out in this project. Anyway, it's neither here nor there. I think we should, instead of creating variables and then testing all of these at the bottom, I think we should just go if return true. I think we should just have like 4 of these, basically. So we have, I mean, we could basically just take the line underscores out, I suppose. Oh, I don't, can we call this from here? I'm not sure if we can actually call this from here. I'll have to find out, though. Okay, but that's only 4 points. Okay. So actually, always the first 4 arguments are the line XY. So I'm going to paste all of those in. Remove all the lines right now. Oopsie daisies. Okay. And then these are different per one because this is basically doing different edges of the rectangle. But I am going to go ahead and just paste them all in and then do a find replace once because I can get rid of the middle part there and be good to go. Okay. And then if we get through all of these and none of them return true, then we know we just return false. This way we won't do, we won't do the calculation for any more than we need to, because we return true as soon as we find one that intersects. Whereas in the Python code, it actually keeps checking, technically. Alright, will it build? And I'll probably be wrapping it up here pretty quick. I will be fairly impressed if it does build on the first try. I'll be even more impressed if it builds and works on the first try. Yep. Okay. Might have just... Yeah. Copied that, but didn't change the name. I'm surprised how long it made it through the process. I mean, I guess it just does a bunch of other stuff first. Oh, that time was way faster. Interesting. Okay. It is running. Does it actually do what it's supposed to? And probably either way, I'll be wrapping up, so either we'll end on a got it right or not so much, and I'll have to fix it later. We can get rid of all this too, truthfully. Let's get back to just more like one of these. And we're doing line rectangle intersects, and then I will grab, oh, yeah, okay, actually, let's do have this. So, yeah, line rectangle. So our line is gonna be the top edge of the trapezoid for now. And then our rectangle is gonna be the moving rectangle. Which, you know, the code completion thing is right about, but there's a bit more to it. We need to do moving rect X, moving rect Y, width, height. So top edge intersecting with the square that moves. Go all the way around, we should get no green. We intersect, we should get green. And we should have green, oh, I bounced the mouse again. We should have green as soon as we start touching it on that side. And then we should also have green as soon as we start touching it on this side, which would be the main visual difference between this one and the last one, since we were testing the left edge before. And now we're testing the whole square. And that seems to be working. So that's pretty sweet. That not only did I have only one thing wrong with the build, it also seems logically to do what we want. We can yoink that code. We don't need to keep the Python code in there. So, yep, I'm going to wrap it up. Thanks for watching. Thanks for the tips to Tyth and C. Grover. Thanks for the follow to X3B00. I should be back next week at the normal time, I believe. However, the caveat I will note is for a deep dive next week. So Scott's potentially going to be doing deep dive, but might not be able to. If Scott is not able to do deep dive, then I will, but we'll be early. We'll be probably like 2 hours earlier than normal. So he normally bills it at 2 p.m. Pacific. It'll be at noon Pacific, which is 2 p.m. my time instead of 4 p.m. my time, which is central. This will be a very essential graphic tool. Thanks for the stream. Yeah, for sure. Thanks for watching. I will see you all later. Have a good day.